So question is, if A equal to set of all 1, 2, 3, 4, B equal to 3, 4, 5, 6, find n of A union B cross n of A intersection B cross A delta B. So first we have to find A union B. A union B equal to set of all 1, 2, 3, 4, 5, 6. So number of elements in A union B. How much? 1, 2, 3, 4, 5, 6. N of A union B equal to 6. Then we have to find A intersection B. So A intersection B equal to common. A and B common. What is common there? 3, 4. Set 3, 4. Then number of elements. N of A intersection B equal to 2. Am I right? Then we have to find A delta B. So A delta B, what is the formula? A union B minus A intersection B. That is equal to A union B. What is A union B? Set of all 1, 2, 3, 4, 5, 6 minus A intersection B. What are A intersection B? 3, 4. Then this equal to set of all minus 3, 4 you have to reject. Am I right? 3, 4. Remaining 1, 2, 5, 6. So n of A delta B, that is equal to 1, 2, 3, 4. Then we have to find n of A union B into n of A intersection B into n of A delta B. So this can be written as n of A union B into n of A intersection B into n of A delta B. That is equal to n of A union B. What is the answer? 6 into n of A intersection B 2 into n of A delta B 4. So 6 2s are 12. 12 into 4, 24 is the answer. Next question. For a set A into A contains 16 elements and two of its elements are 1, 3, 0, 2. Find the elements of A. So here, what are the elements we have? 0, 1, 2, 3. So A equal to, we can take the elements 0, 1, 2, 3. Here it is given A cross A. So A into A contains how many elements? 1, 2, 3, 4. 4 into 4. 4 into 4, that is equal to 16 elements. It is given. Am I right? Then we have to find, for a set A cross A contains 16 elements and two of its elements are, these are the pairs given, relation given. Find the elements of A. So A we have to find it. What are the elements it will come? So already different distinct elements. What are the distinct elements? 0, 1, 2, 3. So this is the answer. Am I right? Let A and B be two sets such that n of A equal to 3, n of B equal to 2. If these are the relations given, that is order pair of orders, that x, 1, y, 2, that is A into B, some of the elements are given. X, 1, y, 2, z, 1 are in A cross B. Find A and B where x, y, z are distinct elements. So we have to find the set A and B. But number of elements is given. N of A equal to 3, n of B equal to 2. A equal to, we don't know. N of A is given. How much? 3 elements. B equal to, said we don't know. So n of B equal to how many elements? 2 elements. But it is given x, y, z are distinct elements. A cross B, sum of the elements are given. What are they? X comma 1, y comma 2, z comma 1. X comma 1, y comma 2, z comma 1. So these are the Cartesian product of A and B. So different elements x, y, z. So we can take A as x, y, z. So number of elements 3. Am I right? Then second number 1, 2, 1. 1 is repeating 2 times. So 1 comma 2. Number of elements 2. So what are the elements A? X, y, z. What are the elements B? 1 comma 2. This is the answer. So if A cross A has 16 elements, so A equal to, you have to know the elements. What are the elements? Some of the elements it is given. What are the elements? 0, first ascending order to descending order, -1, then 0, 1, 2. So it is given A cross A. A cross A equal to, that is -1, 0, 1, 2, -1, 0, 1, 2. A cross A means you have to multiply. Am I right? What are the elements it will come? -1 comma -1, -1 comma 0, -1 comma 1, -1 comma 2, then 0 comma -1, 0 comma 0, 0 comma 1, 0 comma 2, then 1 comma -1, 1 comma 0, 1 comma 1, 1 comma 2, then 2 into this number, that is 2 comma -1, 2 comma 0, 2 comma 1, 2 comma 2. But our question is, sum of the elements it is given. What are the elements? -1 comma 2, -1 comma 2, 0 comma 1, 0 comma 1. And the remaining elements we have to find. But the remaining elements, the condition is given. What is the condition? A must be less than B. That is, first number should be less than second number. So what are the elements it will come? It won't come because it is equal, no? This one, A is less than B. So -1 comma 0, then -1 comma 1, -1 comma 2, then it won't come. It also won't come. Then 0 comma 1, because 0 is less than 1, no? Then 0 comma 2, it won't come. It won't come. It is also wrong. Yes, it is greater than this number, no? 2 comma 2, sir. So 0 comma 2 to this one. Already in the question, -1 comma 2, 0 comma 1 is given. So what are the remaining elements? Remaining elements are, set bracket, -1 comma 0, -1 comma 1, 0 comma 2. That is the answer. Understand? So here some of the intervals and set. How will you write these intervals? It is displayed in the board. First one, open bracket A comma B. Open bracket A comma B. This can be written as x such that A is less than x less than B. This how you read it. X must be greater than A, but it should be less than B. Open bracket, both open bracket means except A and B. What are the elements in between A and B? That is x. Except A and B, excluding A and B, remaining elements. In between A and B, what are the elements? It will come, that is x. X must be greater than A, but it should be less than B. So denoted as open bracket, both sides open bracket. Open bracket in the sense A and B, it won't come. In between that, what are the elements? So here, closed bracket A comma B, including A and B. x must be greater than or equal to a, but it should be less than or equal to b. So a and b also including, that is closed bracket. Then left side open bracket, right side closed bracket, excluding a, including b. A is less than x less than or equal to b. Right side closed bracket, open bracket. So including a, excluding b. Open bracket, both are open bracket. Infinity means it is going on like this. Am I right? Number line. If you draw the number line, if it is 0, 1, 2, 3, etc. up to infinity. Infinity we don't know, so we represent as infinity. So open bracket, a less than x less than infinity. Closed bracket a less than closed bracket a, open bracket infinity. So including a, excluding infinity. So a is less than or equal to x less than infinity. Like that we can. So for example, if I give some examples, you can understand. If I take open bracket 1, 3, how will you write as a set notation? As a set bracket, how will you write? X such that x such that 1 less than x less than 3. X must be greater than 1 but should be less than 3. Suppose open bracket 1, 3, how you write? X such that 1 less than x less than or equal to 3. Suppose here close bracket 1, 3, how you write? X such that 1 less than or equal to x less than 3. Alright? Both side 1, 3. How you write? X such that 1 less than or equal to x less than or equal to 3. Just like if they given us the interval, we can find the numbers in between that. What are the numbers? Suppose open bracket 1, 3 means what are the numbers it will come? 2. There are so many rational numbers, irrational numbers in between 1 and 3 we have. Am I right? So excluding 1, including 3, like that we can see. Next definition, relations. So before seeing this definition, you can see example. When you understand the example, then the definition it will be very easy. So listen here. A and B, two sets. I am taking as A, B, C. Then B equal to X, Y, Z, L, 1, 2, 3, 4. So A is the set containing elements A, B, C. B is the set containing X, Y, Z, L. So this A set represents students. B set represent schools. So A is one student, B is one student, C is one student, X is one of the school, Y is one of the school, Z is one of the school, L is one of the school. Now here some relations we can write. Relations school and students. Am I right? How will you write the relation A cross B? A cross B equal to, it will come A into X, A into Y, A into Z, A into L, B into X, B into Y, B into Z, B into L, etc. Some relations I am taking B comma Y, then C comma L, then A comma X, then A comma L, A comma Z, etc. Some of the relations I am taking. Now this is ordered pair. B represent students, Y represent school, C represents student, L represents school, A represents student, X represents school, A represents student, L represents school, A represents student, Z represents school. So how will you write the relations between these two? B is related to Y. Am I right? C is related to L. Then A is related to X. A is related to L. A is related to Z. So this relation, B is the student of Y, C is the student of L, A is the student of X, A is the student of L, A is the student of Z. Am I right? So here these relations are called Cartesian product of A and B. Am I right? These relations are in Cartesian product A and B. Some of the relations we written. So now come to the definition. Let A and B be any two non-empty sets. A and B be any two non-empty sets. A relation R from A to B. A relation from A to B, that is A into B, is defined as subsets of the Cartesian product. These are the subsets, am I right? B, Y is a subset, C, L is a subset, A, X is a subset, A, L is a subset, A, Z. Subsets of the Cartesian product of A and B. Symbolically we can write R is a subset of A cross B. These are the relations. It is a subset of A cross B. Am I right? Now understand the definition once again. Let A and B be any two non-empty set. A relation from R from A to B. This is R. This we consider as R. R is defined as subsets of Cartesian product of A and B. A into B. Symbolically it can be written as R is a subset of A cross B. So next heading, reflexive. So reflexive, symmetry, transitive. Three headings are there: reflexive, symmetry, transitive. So before seeing the definition, listen here. One set I am taking, non-empty set A. A is a non-empty. Otherwise, the same set itself we can take. S is a non-empty set. 1, 2, 3. Then we have to find the relation S into S. S into S, how will you write the relation R equal to? That means S into S. R equal to, say, 1, 1, 1, 2, 1, 3. Then 1, 1, 2, 1, 3. Then 2, 1, 2, 2, 2, 3. Next 3, 1, 3, 2, 3, 3. So these are the Cartesian product of S. Am I right? That we denoted as R. So 1, 2, 3, 4, 5, 6, 7, 8, 9. 3 elements. How many elements we will get? 9 elements. Now I am going to explaining the reflexive here. So reflexive, if you take 1, 2, 3 are the non-empty sets, non-empty elements, that is 1, 2, 3 are the elements in S. 1, 1, 2, 2, 3, 3. Now come to the definition, reflexive. Let S be a non-empty set, S be a non-empty set. Let R be a relation, this is the relation on S, then R is, this R is A, A belongs to R. For all A belongs to S. A, Here what is A, 1, 1, 2, 2, 3, 3. That is reflexive. Am I right? 1, 1, 2, 2, 3, 3. These are called reflexive. This 1, 2, 3 belongs to S. A, belongs to R. For all symbol. For all A belongs to S. Then symmetry. If I am taking 1, 2, 1, 2, there must be 2, 1. 1, 2 means there must be 2, 1. Whether 2, 1 is there? Yes. So if it is S is a non-empty set, let R be the relation on S, then R is said to be symmetry if A comma B belongs to R, 1 comma 2 belongs to R, then B comma A, that is 2 comma 1 also belongs to R, that is called symmetry. So if I take 1 comma 2, there must be 2 comma 1, am I right? Yes. This 1 and 2 belongs to S, for all 1 comma 2 belongs to S. Suppose if I take 3 comma 2, what must be there? 2 comma 3, 2 comma 3 is there, am I right? If I take 3 comma 1, what must be there? 1 comma 3, alright? So it is called symmetry. Then come to next step, transitive. Suppose if I am taking the elements 1 comma 2, 2 comma 3, there must be 1 comma 3. Check it in the relation, check the relations. 1 comma 2 is there, 2 comma 3 is there, 1 comma 3, yes. So what is the condition? If, transitive, if A comma B, B comma C, 1 comma 2, 2 comma 3, A comma B, 1 comma 2, B comma C, 2 comma 3, then we have to get 1 comma 3, that is A comma C, 1 comma 3, alright. Now understand the definition once again. Reflexive means let S be a non-empty set, R be the relation. Relation, you know that to find Cartesian product, am I right? Cartesian product of S into S. That is, let R be the relation on S, then R is, that element should be, if it is reflexive, if you want to say it is a reflexive, what is the condition? A comma A belongs to R. What it is symmetry? A comma B implies B comma A. Transitive means A comma B, 2 elements, 3 elements. A comma B, B comma C, then it should be A comma C. Understand? Then equivalence relation. Equivalence relation is nothing but if the condition, if this relation satisfy all the 3 types, reflexive, symmetry, transitive, then we can say it is an equivalence relation. So this R is an equivalence, whether it is an equivalence relation or not, yes, because R is reflexive, am I right? 1 comma 1, 2 comma 2, 3 comma 3. In this element non-empty set, 1 comma 1 is there, 2 comma 2 is there, 3 comma 3 is there, it is reflexive. Whether it is symmetry, if I take 2 elements, 1, 2, 2, 1 is there, correct? It is reflexive, symmetry. And whether it is transitive, yes. So you can say this relation is an equivalence relation. So better if they ask definition, you can write this example itself. So dear students, in exercise 1.1, first sum, second sum, third, fifth, seventh, these are the basic sums. You may study it in 10th standard, that's why given as homework. Just try to do these problems, then you will get some basic ideas. You can recall whatever you studied in 10th standard, am I right? So example 1.9 also homework, okay? So when you complete these problems, that is, you comes to know that up to exercise 1.1 it is clear. Am I right? Then today we saw this definition also, am I right? Relations. Relation definitions we saw, that is reflexive, symmetry, transitive. Then both these, 3 conditions satisfied, then we can say it is an equivalence relation, am I right? Equivalence relation. So the definitions you should study clearly, understand? Then only you can do the problems. If you know the definitions clearly, problem is nothing. If they ask some problems, you can solve it directly. So dear students, please understand and study this reflexive, symmetry, transitive, and what is equivalence. Am I right? Thank you.